Today we discuss the next point, normal order of fine structure doublet. In that article, we explain about the normal order states of the fine structure doublet. As we discussed earlier, the observed fine structure in alkali spectra is due to the energy level splitting, and that result is the effect of the introducing spin motion of an electron. Hence, the electron not only revolving about the nucleus, but it also revolving about its own axis. Hence, due to orbital and the spin motion of electron, each electron possesses spin angular momentum and orbital angular momentum. In that, the spin angular momentum is an integral multiple of h divided by 2 pi, where that integral multiple small s is known as spin quantum number, and in orbital angular momentum also possess the integral multiple of h divided by 2 pi. That integral multiple is small l, known as orbital quantum number. Now see here, as electron revolving about the nucleus, it possesses the orbital motion, that its orbital angular momentum is in the direction of the magnetic field produced by the orbital motion. Means magnetic field B and L both are parallel. As the electron spin motion we just take into consideration, that electron is also revolving about its own axis, and if the direction of the spin motion is opposite to that of the orbital motion of an electron, both are oppositely directed. But the spin motion of an electron also associated with the magnetic moment. That magnetic moment is opposite in the direction of spin angular momentum. Both are opposite in direction. It means magnetic moment due to spin motion and magnetic field produced by the orbital motion both are aligned in the same direction. And if B and mu s, magnetic moment due to spin motion and magnetic field produced by the orbital motion, both are aligned in the same direction, it results into one of the state, and that state is J equal to L minus S. What is J? J is total angular momentum. The total angular momentum is the result of spin angular momentum and orbital angular momentum. In that case, if orbital angular momentum and spin angular momentum both are oppositely directed, then it gives the resulting total angular momentum is J equal to L minus S, and it is one of the state. That state is L equal to J equal to L minus half. If J equal to L minus half, in which case if L and S are oppositely directed, in that case the energy state of electron in that alignment is always smaller, means it is more stable. And if it is more stable, the energy state under that alignment always lies deeper as compared to other state. Now what is the other state that we shown here? Same as due to orbital motion, it possesses the magnetic moment, magnetic field and orbital angular momentum both are parallel. But what is the Alignment of the spin motion. The spin motion electron also spin about its own axis, and that direction of the spin motion is same as orbital angular momentum, means both are in the same direction. Naturally, its magnetic moment is opposite direction, means mu s is opposite to that of magnetic field produced by the orbital motion. In that alignment, if mu s is oppositely directed to B, then it results new state. That state is J equal to L plus S. Now, how get the J equal to L plus S? Since L and S are in the same direction. Therefore, the total angular momentum is the sum of L and S, L plus S. Hence, J equal to L plus S, it means J equal to L plus half. In such a alignment, the energy state of the electron is always higher. And if energy is higher, that state becomes unstable. And unstable state always lies above the stable state. It means in the doublet terms, as we mentioned earlier, doublet P, doublet D, doublet F, all these terms, each P term splitted into doublet. In that doublet term, one is J equal to L minus S and other is J equal to L plus S. J equal to L minus S means magnetic field and magnetic moment both are in the same direction. It results most probable state, that most probable states having less energy, and less energy states is more stable. Therefore, it lies always deeper as compared to other J equal to L plus half state. That states we have to just draw it here. For doublet P term, there are two terms. One is doublet P half, other is doublet P 3 by 2. In that, doublet P half is always lies lower as compared to doublet P 3 by 2, since this is more stable, having less energy, and that state is most probable state. Similar result we observe in doublet D term and doublet F term. But in certain cases, as the higher J value lies deeper, then that terms known as inverted terms. We refer these terms are inverted terms only when if higher J values lies deeper. Hence remember, the normal order states for each doublet term, lower energy state always lies lower since it is more stable as compared to other state, and that is the result.